So the third paper is about new compression techniques in next generation video, presented by Thierry Fortier. As Vice President of Video Strategy at Harmonic, Thierry Fortier is in charge of defining and driving the execution of the long-term strategy of Harmonic's video business. In addition, Fortier is the current president of the Ultra HD Forum, the global organization responsible for promoting market adoption of UHD by defining industry best practices for the phased introduction of the right set of technologies that will facilitate the next generation viewing experience. Please welcome with me Mr. Thierry Fortier.
Okay, so I hope I will be able to entertain you on the subject of the future of video compression. And this is actually a very good continuation of the content-aware encoding, the QBR, the machine learning. You will see those terms coming quite often. So first part of the presentation will be where we stand today, codecs, bit rates, and what is available bandwidth. Second, I will call that breaking the compression wall, what we need to change in MPEG in order to move to better compression efficiency. And then I will start to give you some potential numbers based on the research we are doing in Harmonic and based on what has been published. So first, we are going to discuss bit rates and video quality. And for all those of you who know very well video, and you heard that in the presentation earlier today, there are multiple tools to look at objective measurement of video quality. So to list only few, PSNR, DMOS, SSIM, VMAF, and last but not the least, Harmonic has also developed its own technology of video quality assessment. The big difference is this is compared to VMAF running in real time. So there's no real agreement on objective methods to put that in the standard. I know MPEG was looking at VMAF but did not accept it, so your mileage may vary, as we say in English. So where do we stand in terms of codec? So first, H.264 was created in 2003, probably the most deployed codec, I think even more than MPEG-2. Then came HEVC, and then on the roadmap of MPEG, there is a new codec. For time being, we call that JVET because it's a joint video expert team who is basically between ITU and MPEG, and this is for 2020. So we were able to reach about 10% efficiency every 10 years, and here we are also trying to shrink it to do it maybe in 8 years. So is that all? Absolutely not. We have VP9, as you know, which is the codec that Google is trying to push to the market with little adoption so far. And we have the Alliance for Open Media, who has a claim to provide 40% efficiency over VP9. So as I say, the race is on, meaning there are many different technical solutions to solve the same problem. So let's look at the bit rate. So if I say, based on, I'm trying to give you all the time which are my references. So this was a paper Netflix provided in 2016, measuring VP9 versus HEVC reference. And then I took out of the claims of AV1 versus VP9 what would be the AV1 performance. And then I put also 50% bandwidth reduction on HEVC for JVET. So this is where we think we will be in the coming years. So let's look at the different bitrate requirements. So in terms of standard definition, we talk about 72480 for about 1.5 megabit in AVC. Then you have the HD resolution either in AVC or HEVC, and you saw Apple supporting HEVC, which is a good news for all of us who are working in that codec. Then you have the legacy VR application, which is 2560 1440p 30, still at 15 megabits per second. And then you have the UHD resolution P60 in HEVC, which is 20 plus megabits per second. So I would say HEVC covers pretty much majority of existing application. Of course, if you go to challenge network, wireless, emerging country, this is absolutely not sufficient. So interesting to see what is happening on IP, because we know that IP is going to be a very big driver for consumption of content. So I've taken some numbers out of the wired internet speed, and you see all over the world it's pretty low, 6.3 megabits per second. Then if I look at 3G, 4G speed, we are about at 10 megabits per second. And now the roadmap for wireless is pretty impressive until 5G arrives. So please be aware this is including 2G, 3G, 4G. 5G only arriving in our numbers in after 2020. So this is only the 5G, before 5G. And we still see a constrained bandwidth in the OTT world. If you have to go across the public internet, if you have to go on a mobile network, you will not go beyond 10 megabits per second, meaning no UHD, no VR, which could be a problem if we project ourselves in 2020. Now, this one is much more interesting because this is the world we are going to live by 2020 and beyond. And you look at VR, if you use styling technology, so basically what we call the field of view approach, you can go for HD transmission around 2.6 megabits, for UHD transmission around 9.8 megabit. Now, if you increase the frame rate to P120, you have to increase the bandwidth. And then if you start to bring higher resolution for broadcast application, and if you start to touch 8K, I know NHK is crying when they look at the bit rate, 65 megabits per second is very high. And of course, if you start to talk about 6 degrees of freedom for VR, you are in the gigabits per second. I do not believe there is a business model yet to support this type of application. So, to summarize, UHD P100 will be a challenge. We start to reach high bit rate. Everything 8K and VR 6 degrees of freedom, we have no technical solution to address those new applications. So let's talk about the world we live in. Today, when I go to MPEG, people tell me you have an encoder, you have a network, and you have a decoder. It's most of the time today when we build an encoder, it's a fixed function appliance, even if it's a software-based implementation. We are dragging this PSNR rule for the last 20 years. Try to get rid of the addiction, it's not easy. On the decoder, if you talk to any MPEG expert, they tell you, oh, decoder is limited performance, cannot do a lot. It's cost-driven, has to be cheap, not enough memory. So a lot of limitation on the decoder. And then if I want to use a post-processor on the chip or on the TV, it's absolutely non-standard. So nobody is guiding the post-processor. So this is the world we are living in today. A lot of luggage to carry. And of course, we limit ourselves. If you try to run 100 meters with 2 suitcases, you probably will not win the race. So let's look at what we can do. First, we can do a pre-processor before compression, and we can couple that with the decoder, and then you carry metadata and you instruct the post-processor what type of pre-processing was applied. Second, we have to be a bit modern, and I'm quite happy to see at SMPTE now cloud is starting to be part of the conversation. We can encode in a much smarter way if we have more CPU power. And I'll come back on that. Then the decoder. We all know the decoder is getting more and more sophisticated. If you open a smartphone today, there's a lot of processing capability. So we can leverage that processing capability. Last but not the least, we can instruct the encoder to do much smarter thing, and you saw in the session this morning, machine learning is something which is going to help us to reach much better efficiency compression. So if I put all that together, if I bundle all those functionality, I will try to convince you we can go way beyond where we are and therefore enable new applications. So what are those tools? The first one is what we call elastic encoding. If I increase the CPU resource when content is more difficult, I can access to more modes in my encoder. I can therefore reach a better compression. Machine learning, I teach the encoder how to encode using AI techniques. Pre-post processing, I couple the post-processor with the preprocessor using standardized metadata. Content-aware, I use bit distribution based on the psychovisual model, and all those tools could be enabled on today's technology. So let's look at simulation about HEVC, which today will provide, I would say, compared to what we have today, if I project myself in 2020, I probably can save 35%, this is assuming 10% efficiency gain every year. So if I use the core codec 34%, if I use content-based encoding, I expect to save 20%, and this is based on products we are today releasing. The elastic encoding, based on what we do on dense transcoding, we know when we do dense transcoding, we lose 15%. So if we give more CPU, we expect to save an additional 15%. Machine learning, you saw very promising number. I put the numbers down here, only 15%. And the pre-processing, we have technologies today who are deployed in the market, standard, non-standard solution that can save 15%. So if I compare to the bare-bone HEVC, I can save 70% using new techniques. And this is the backing facts behind all the numbers. So basically, we can do much more with HEVC than we do today, just thinking out of the box, using new techniques, using the same install base of decoders, except for the post-processor that could be upgraded. But if you have 32 cores in 2020, I'm sure you can find some of the core to do the job of post-processing. So let's look at what MPEG is doing. So JVET, Joint Video Expert Team, is basically a group between ITU and ISO working on the next generation codec. There's a call of evidence that was published in July. This week, there is a call for proposal in Macau. There will be a standard candidate to be released by 2019, and there will be an international standard that will be released by 2020. So if I take similar things, if I look at what HEVC can do by 2020, and if I use a different codec, maybe I will not get better performance by 2020, but I expect by that time, if there is JVET is helping people to build a better context-based encoding with some test pattern that we can use, I can expect to have a better efficiency compared to what we are doing today. Same for the elastic encoding. If MPEG gives us much more tools than we have today, doesn't limit the performance of the encoder, we can use those tools in an elastic way when we need it. Same for machine learning. People are doing experiments in their lab. If we get test pattern from MPEG, maybe we can get access to much better compression efficiency. And here, if we have standard-based metadata, I'm pretty sure we can go way beyond the 15% I mentioned before. So if I apply the same techniques to a new codec, and if MPEG let us do new things, I'm pretty sure we can go way higher than the 50% improvement that MPEG is promising to the industry. So this is my prediction on what is going to happen in the coming years. So you have nothing changed for HEVC AV1, JVET, but you see my boosted HEVC, which is using the HEVC syntax, has the potential to perform better than the JVET codec using install-based decoder. And of course, if you use those techniques for the JVET codec, you can even get it down to a very, very aggressive. You see, we move from 100 to 20, so we divide by 5 the bandwidth. So what we propose could potentially be a game changer. No need to change the decoder. MPEG has to help us, and we can bring you much more efficient compression techniques that will help to enable those new applications. So to conclude, new application will require a new compression scheme, even on new networks. Do not think 5G and fiber is going to be all over the world. Compression needs to be revisited if we want to go beyond the 2x every 10 years. Harmonic proposal can gain 3x on HEVC using HEVC installed base decoders. And the proposal we are making to MPEG is something that can go up to 6x compared to HEVC we have today. And of course, as always, we are committed to reinvent the compression. Thank you very much.
Okay, ladies and gentlemen, do we have some questions? Maybe I ask a question first. You listed the potential improvements for different methods, and you added these improvements. So is there not a cross influence between the different methods?
Yes, but as we have not put all that together, we don't know yet. But I can say machine learning is pretty horizontal. For example, pre-post processing pairing, I believe, is something that can work independently of the codec, and all the elastic cloud technology. We assume if we have more CPU, we can reach better performance. Of course, this needs to be demonstrated, and my paper was not accepted at IBC. They told me you have no simulation to show your claims. But this is more an idea, a perspective I want to give to the industry, and especially to open the mind of people inside MPEG who are thinking very much inside the box. And I think we now have the tools to open new discussions in a cost-effective way.
Ben Wagner, Amazon. For the boosted HEVC, where you have a couple preprocessor or post-processor, is there a proposal or thoughts about what that metadata that would be passed on to the decoder would be?
Yeah, so today people are doing that in a proprietary way. Actually, people are deploying system without any metadata. The decoder by himself does some de-ringing and adaptive upsampling based on the content. But I know companies are doing pre-post-processing pairing in a completely non-standard way. So you might want to do that on your network since you control the head end and the client. But if you have different client like a service provider, it doesn't always control the client.
Is there any work happening to try to come up with a standardized?
No, there's no standard yet. But I'm throwing the ball for people to take that as a contribution to MPEG. I made mine 1 year ago.
Okay, I like it.
Thank you. I have a customer.
So yeah, we have some more time. So do you have some more questions?
I thought this would be more controversial.
Now it will
Peter
become
woke
controversial.
up. Peter woke up.
Not attempting to be controversial, but there's a fascinating list of areas. It would seem, at a quick thought, that Harmonic or whoever could, if they wish, go ahead and demonstrate what could be achieved with elastic processing without changes to the standard.
Yes.
And I wonder if that's part of your plan.
Yes, so we are doing that, but for time being, we are focusing much more on machine learning because it's a quick bang for the buck. But on elastic encoding, what I gave as a target to my team is give me better compression in less CPU and less power per day. Because at peak time, the soccer match is probably going to take a lot of CPU, but after the advertisement at midnight, nobody watch. And today, if you look at the way a system is built, it's the same encoder 24/7. Nobody says to the encoder, you should do this, you should do that. So I think we have a lot of leg room.
Hello, Terry. Scott Davis, Parts Unknown. Hey, I see a lot of work being done in this area, specifically on the rectangle. You and I are both aware of the fact the whole world has this whole view of 3D modeling and 3D objects in a virtual space. Are you thinking about any of the implications of 3D objects in that space while you're thinking about your compression
You
options?
talk about 3D modeling for objects or
Yeah.
more like VR distortion?
Yeah.
Which one?
3D object modeling.
Okay, they tried that 10 years ago in MPEG. They could not reach any meaningful results. I think even today on JVET, this is off the table.
Okay.
My take is that VR is going to impose different techniques, and I'm very happy to see in MPEG there are test video clips which will be VR, HDR, so we'll have, or at least this new content, but the modeling, it's a bit, the 3D modeling is a bit science fiction, unfortunately.
Okay.
But as you can see with the numbers I'm showing, I think we can do a lot of great job with what exists today.
Thank you.
Maybe one question from my side again. So what we have seen in the different methods is in many cases more or less an optimization of the encoding process through different methods. How much improvement can be achieved by, let's say, new methods or different ways? So are there any ideas to use a different
You took
coding
new
approach?
New codec.
Yeah.
Well, this is the JVET approach. It's
Okay.
50% bandwidth saving. The problem I have with JVET, we are running for another round of 3 or 4 years. We need to change all the decoders, and then you have the patent lawyers waiting for you at the exit of the room, asking for more money. Are we all ready for that?
Okay, maybe on your experience, you have shown that H.264 was, let's say, out in 2003. So how much improvement was done in the industry based on the original H.264, I think?
Yeah, I think per year is about 10% improvement, but what's interesting with adaptive streaming, what we have done with this content-aware encoding, we can use the VBR-ness of the network and the device, like iOS 11, and then you can reach even more because you put the bit in the proper way. The H.264 was not designed for that type of behavior. VBR was part of the spec, but now we use it in a certain way, which make us gain. You saw the QBR number, like 35 to 40%. I can show you easily CBR versus IQ, our technology of content aware, 50 to 60% bandwidth saving without impacting the quality. And is Kumar in the room? No. Without changing the client. Existing client can decode VBR because they are modern clients, they are not set-top box built 25 years ago. So I think this industry needs to realize existing tools need to be used properly, and we need to use the technology that are available today to improve the efficiency of the system. We don't necessarily need a new syntax.
Okay, Thomas?
Thomas Edwards from Fox. So you were talking about these improvements as a scalar number across perhaps an entire clip, but in fact, when you're talking VBR, it's really a vector. Something I'm concerned about is I'm not sure that we're improving the bit rate at the area of highest complexity,
No.
both temporal and scalable. I think we're doing a great job of crushing down the simple scenes.
Yes.
I don't know whether we're doing such a good job with the complex
That's
scenes.
correct.
I was wondering if you could
Yes,
discuss
so
that.
if you want to reduce the bits you spend on complex scenes, you need a new codec. But Thomas, do you know how many HEVC devices are in the field today? How many? 2 billion. What do you do with those devices? You say you need to buy a new device, you need to go to lawyers who are asking for more money. I mean, this is a bit the challenge we have today. It's like everybody would like to deploy HEVC, we can't deploy HEVC. Okay, so we do other tricks in order to work to make longer life to H.264. But I agree, if you want to improve the core compression technique, I think you need to use a different codec. But look at the elastic encoding, machine learning, you put the bits in a smarter way. You saw all the presentation, people are throwing bits at the wrong places in the video. So I think we have good tools. We need to work harder on existing standards and not dream about new codec. And this applies to AV1, by the way. It's not only JVET. AV1 will be faced with the same problem. It's not JVET specific.
Okay, thank you very much, Thierry.